All right, folks, here we go. This is the state of the sun. So where we are right now, we can see that these are the sunspots on the sun right now. There are a couple of different active regions, but we don't really have a whole lot in terms of magnetic complexity. We have some good size to some of these sunspots. The most complex one, I don't know if you guys can see this all the way over here on the limb, this little group coming in over here on the north, that's probably the most complex one we have, but there's not a ton of development or size to that one. To give you an idea of what such a sunspot would look like, this is back in May of 2024. This sunspot down here is the one that caused all of the big geomagnetic storms last summer. And so this is what a complex sunspot looks like. Actually, this one up here, which didn't cause geomagnetic storms, had a couple of X-class solar flares that didn't really produce much in the way of coronal mass ejections. But you compare that to what we have on the sun today, and you can see even though some of the spots have some okay size, they're not jam-packed in close together. There's not a ton of magnetic complexity. What this tells us is that these sunspots are very unlikely to give us a big solar flare unless they develop, grow, new spots come into the mix, etc. We went over this a little bit yesterday, but I want to go over some other points. So these are the last, I'd say 10, 11 sunspots. Actually, how many are there here? Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the last 11 sunspot cycles. And if you'll recall, we had that excellent question in the middle of the live stream yesterday. Do we expect a second peak to this sunspot maximum? And when we are looking across this much time here, we can very easily see how some solar cycles, like this one, has a double peak. This one technically has a double peak, although there was activity in the middle of the peaks. This one, I don't even really know if you could say it had any peaks. It's just kind of flat. So far, this sunspot cycle that we're in right now looks a lot like the one about 110 years ago. One single peak, sort of a sharp rise, sharp decline. There is something else I want to mention. Almost every single one of these sunspot cycles had a declining phase, serious geomagnetic storm. Sometimes you can see that showing up in the sunspot data. So for example, this is actually a good one right here, if I can zoom in on that. Okay, so you see this one. This one's on the decline, and it's halfway down, and we get another jump up like that. Here's another good example over here in the early 70s. It doesn't always show up. Sometimes it's just a one-off sunspot group. But that is what I was talking about yesterday about the geomagnetic maximum. Not only do we have the coronal holes more prevalent during the declining phase, but we usually get at least one declining phase uptick in sunspots. So we come back to where we are right now, just this sunspot cycle, and as we were talking about yesterday, nobody knows if this is just going to careen downward towards sunspot minimum or if we're going to have another sunspot maximum peak here at some point in the next couple of months. There's something that's really interesting I want to show you guys. So this is the current sunspot cycle, the last 11-year cycle, and then the one at the turn of the millennium. We can see how much weaker last sunspot cycle was compared to at the start of the millennium. And we can see here that we have definitely exceeded what happened in the last sunspot cycle, much to the dismay of people like Valentina Zarkova, who insisted we were going into grand solar minimum, who wrote terrible articles about me for saying we weren't. Obviously, we have not gone into grand solar minimum. I don't see any evidence that that's on deck right now. But essentially, this is something interesting, and it's not just the sunspot number that's a little bit elevated. Let's take a look at the radio flux. So this is the radio flux, and I'll pull this in a little bit so we can see just last sunspot cycle and this sunspot cycle. The radio flux is driven by solar flares and coronal mass ejections. It's not the same as sunspots. You know, we can have a ton of sunspots on the disk. Maybe they don't give us much at all in the way of flaring. In fact, that's pretty much what we have on the sun right now. There's several sunspots. In fact, the sunspot number is over 100 today. But we don't really have much in the way of flares. What the radio flux progression tells us is exactly how much of that solar flaring and CME production we're actually getting. And so even though from a magnetic standpoint, the sun is about where it was 11 years ago, but the sun's been significantly more active than it was last cycle. Another way to look at that, we're looking at the thermosphere, the temperature in the thermosphere. Now, we are today, you know, in this sunspot cycle, we're nowhere near some of the previous ones we've had. But you take a look at the last sunspot cycle, and we are, I mean, double the power in terms of the thermospheric temperature forcing of the solar activity. And even the very first little peak we had was significantly larger than anything we saw in the last sunspot cycle. Now, over here, because we're talking about a power law index, it's not exactly the same as if it wasn't a power law. So this kind of looks like, oh, maybe it's about double. It's actually about 100 times more forcing. And we don't have 100 times more forcing in terms of the radio flux. We don't have 100 times higher sunspot number. The thermosphere is one of the first layers up at the top of the sky that gets way more vulnerable as Earth's magnetic field is in the decline. And so one of the reasons why this is so high is not just because of the higher sunspot number. If we actually go back and we take a look at some of those sunspots, you can see, all right, obviously we're higher than we were the last sunspot cycle, but take a look at this sunspot cycle compared to 2 cycles ago. It's really not even a comparison. 2 cycles ago was significantly stronger. We would need to have a wild resurgence in sunspot maximum here in these sort of later years of the maximum to come anywhere close to this. But when we pull up the thermospheric climate index, you can see that we actually have come pretty darn close to where this was. Why is the thermosphere reacting similarly to what it did 20, 25 years ago, even though the sun isn't as active, isn't as powerful? We're losing Earth's magnetic field and the ongoing magnetic pole shift, leaving the upper layers of the atmosphere more vulnerable to that solar forcing. Another thing I want to show you guys, this is the neutron monitor, and this is really what we're focused on down here. This is, since the 60s, the cosmic ray counts. And so what you can see here is this is how much the sun is pushing stuff away. And it runs opposite to the sunspot cycle. And so here's where we are right now, which is pretty comparable with 2 cycles ago, even though what the sun is delivering is nothing even remotely close. And so what this tells us is that there is something else that is blocking out the cosmic rays. Now, that is not due to the magnetic pole shift, but it's likely that we are getting deeper and deeper into the galactic current sheet, which itself, like a coronal mass ejection, even though it is an energetic thing affecting what it touches, it also blocks out the outside. So when Earth gets hit by a coronal mass ejection, we get auroras, we get a geomagnetic storm. We're certainly being impacted by that energetic plasma from the sun, but while that is happening, the cosmic rays from the galaxy go down because Earth is shrouded in an electromagnetic plasma cloud that basically acts as a secondary field. The reason why we're seeing the same level of drop in cosmic rays that we did 20, 25 years ago, despite the fact that the sun is nowhere near as powerful, we are getting deeper and deeper inside of that magnetic current sheet, the electric current sheet, which acts to sort of block out some of those extra cosmic rays. Last thing I want to show you guys, this is the solar polar field data, the entire data set. We are over here on the right. It was right about here, about 2015, 2016, where I started saying, guys, there's no chance of us getting a grand solar minimum, because the magnetism was already showing that it had some juice in it, even though the northern fields didn't spike down as quickly as the southern fields in red did. I could quickly look back here and see, okay, wait a minute, that's about what the last sunspot cycle did. And so how high and how low these spikes go tells us how much solar activity we should have. And so you look back, okay, it's understandable that these sunspot cycles had a lot more sunspots. Look at the magnetic power of the sun compared to the last sunspot cycle. But you compare these two and they're pretty on point in terms of the magnetic power, yet what has the sun been doing? The sun has been doing a little more than it did the last sunspot cycle. Now, whether that is just a random configuration of how the magnetism has played out over the last couple of years, or whether that is the galactic current sheet providing a little bit more instigation to the sun, sort of an open question. But where we are right now, this was basically the solar pole flip about 2003, 2004, and the lines are starting to just separate again now. So we're basically here, we are in this area, we're in this area, and it won't be until we get that first big spike that we can tell whether or not we're going to have a grand solar minimum, make a forecast about sunspots in the next 11-year cycle, etc. And so if you see something online where somebody's talking about, oh, like we could be going into grand solar minimum, it's a wonderful guess, it's lovely, I'm glad that their head is in the space weather game, but as of today, there is not one single thing that could tell us one way or another whether or not we're going to dive into grand solar minimum, what the power of the next sunspot cycle is going to be. It's not until we get these bigger spikes starting as we come out of the polar reversal of sunspot maximum. That is when we will be able to finally actually make a forecast for the next sunspot cycle. In terms of when that sunspot cycle should be coming, the pink area over here, which is the forecast, it extends a little more than I think it actually will extend if we actually come to here. They sort of show this sunspot cycle bleeding down into like 2031 or so. I think that that's probably pushing it. By 2030, we really should be at the bottom of sunspot minimum, and we should probably be in sunspot maximum again somewhere around here, 2035, 2036. Maybe we'll start to see things in 2034. But so this is when I'm really sort of concerned about Earth's magnetic field reaching such a weak point that our civilization doesn't hold up. For those who were watching me at the start of this sunspot cycle, this was maybe 2020 or so, I was saying there's probably only about a 25% chance that our magnetic field is weak enough that we go down this sunspot cycle, meaning I thought back in 2020 there was about a 75% chance we were going to get through this sunspot cycle without a major blackout. With where we are right now, having gone through most of it, I want to say that's probably up to like 90% sure that we're going to make it through the rest of this and get into sunspot minimum. But when we get to the next sunspot maximum, especially if there is a considerable weakening of Earth's magnetic field at some point in the next 10 years, we probably wouldn't be able to take something like we took in May of last year, certainly not what we took at Halloween in 2003. And so this is, if you're looking ahead a little bit further, this is sort of the time to be concerned about. I'm considerably concerned about this. If we take that out even further, the sunspot maximum after that will be in the middle of the 2040s, 2045, 2047, something like that. And by that time, I would be relatively surprised if Earth's magnetic field had allowed us to just trot along with modern electrified, electro-dependent civilization. So quickly to review, it's the next sunspot cycle we're looking at will probably be in the 2030s. I am almost certain that we're going to get there without a major space weather blackout event. At this moment, I would say it's probably 50-50 of us getting through this one, with the percentages going down if you jump to the 2040s. From the solar polar fields perspective, there's really nothing we can look at right now. And the reason I decided to throw this in here, I'm starting to see more of those grand solar minimum videos popping back up again. Just be aware of that stuff. I like David from Adapt 2030 as well. I like him a lot. He's a friend of mine, but he's often wrong on this stuff. So just something to think about. From a cosmic ray perspective, we can see the impact of what I believe is the galactic current sheet, because you can't explain this drop in cosmic rays just with the space weather. Same thing with the thermospheric climate index. This one, I think, I would expect it to be higher than last cycle, but not almost as high as 2 cycles ago. That probably is the extra vulnerability of our planet due to the weakening of Earth's magnetic field. And of course, we are still waiting to see if we're going to get another peak here at the end of sunspot maximum before we descend into sunspot minimum. Now, I'm going to quickly, we're going to do some questions, and the gentleman who asked the good question yesterday's got another one. You want to go ahead and?
There seems to be an increasing like you said.
Yeah, so the question is about patterns in sunspot cycles. You do certainly notice that. If you go back further in time, that one's harder to see. So like in the middle of the 1800s, those sort of patterns just sort of fizzled out. But what actually that is it's not 4 sunspot cycles, it's actually 8 sunspot cycles together, and this is the Gleisberg cycle, approximately 88 years. So it's good on you. I mean, it wasn't up on the screen that long, and it hit your eye pretty easily. I mean, this is the Gleisberg cycle right there. That's exactly what that is. Yeah, August. Yeah, that's an interesting question. I was actually wondering that not terribly long ago. So the question was about other magnetic cycles sort of showing up. There is definitely an underlying cycle that's in play as well here. So like, for example, the Hallstatt cycle and its shorter harmonics. That's 2,400 years, 1,200 years, 600 years, 300 years. But those are completely different from the 11-year sunspot cycle, the 22-year Hale magnetic cycle, the Gleisberg cycle, or the solar flare cycles of 150 to 200 years, 1,000 years, 3,000 years, 6,000 years.
Remember that movie Contact? When they got
The movie Contact. Of course I remember the movie Contact. Yeah, that's an interesting thought, and if you couldn't hear him, he was just going over some of the other things that we observe like this. I would imagine this is the kind of evidence you would look for. I don't know how I could possibly think I could like give a definitive answer, yes or no, but this is kind of the thing you'd be looking for it to pop out of nowhere there. You got another question or two here, yeah? Oh, yeah. Tone is here, and he's running across the room with the microphone. He's recording this too. So that was a good question. He was asking where the instruments are located that generate that data. So sunspot number is tracked from satellites and from the ground telescopes. Solar radio flux is largely tracked via satellite, but there are some ground-based ionospheric machines that could do it. Those ground-based ionospheric detectors are where the entire thermospheric data comes from. I would say, I mean, pretty much everything is either an Earth orbiting satellite or a ground-based telescope at this point. Was there something specifically you wanted to know about? No, fair enough. Fair enough. All right, back of the room, Doug, and you're going to have to wait for Tone to get back to you. Tone, you're getting your cardio in here.
So given that these are tracked by we hadn't so line at that point.
That's interesting. And so he's asking about a sub-solar kill shot-like event. So let's say the magnetic field keeps weakening and we get something exactly like May of 2024. Maybe it doesn't take out the global power grids, but it takes out all or most of the satellites. Well, that would make my job a lot harder for sure. I would say if that happens, everybody should probably just have it in their heads that the end is coming not too far after that, because that would be a very serious event, and that would really tell us. I mean, unless it was something like if it was like an X50 or an X70 or something, then you'd expect that. But if it's just something like a couple of X-class solar flares mixed with a coronal hole, yeah, I think that would be a pretty clear sign that the end was very close and that Earth's magnetic field had dropped a lot more. I see August's hand going up again. Tone, you want to run over there?
Yeah, but without those satellites and there's no internet, they can just say it's X50 through the radio channels. If you can't.
No. Well, all right. So Tone's comment was, if all those satellites go down, they could just tell us it's X50. Basically lie to us. I don't think they could do that because it wouldn't happen the moment of the flare. You know, within a minute of the solar flare, we know the strength, and it would probably take at least, even if there was a magnetic crochet from the flare itself, that would still take dozens of minutes. The CME would be hours to a day or two away. So maybe they could.
Very few control the radio signal. You can't get your word out.
True.
But shortwave, that's not gonna answer.
If we got something like an X40 or an X50, I would be live instantly. Like, I'd be screaming. You wouldn't even need to go online to hear me. I would just walk out my front door and just start screaming up into the sky as loud as I could.
Okay, well, the question I had is
Well, so, yeah, the question was about all the things we have to worry about. And so I come back to the four phases of disaster. You know, the final one is the next stage of Earth where, okay, we're in the aftermath and got to rebuild. Then the third one is that week of cosmic hell where the sun turns black, micronova happens, the Earth turns over. Phase 2 is there's no more power grids because Earth's magnetic field has allowed the sun to take everything out. And then phase 1, where we are now, is Clown World. And in Clown World, the sun, Earth's magnetic field, the galactic current sheet are not our biggest concern. It's the idiots running this planet, the group of individuals who seem to control the idiots running this planet, who also control all the media, etc., and also happen to be buying up all the VPN sites and own most of the porn websites. We all know who I'm talking about. We have any noticers in the room? Yeah, I think we have a lot to worry about from people before then, and whether that's cultural, social, political, or economic. All right, we're coming up front here. Wait for Tone to run across the room.
How to have any interaction?
Nobody knows how big the field is around 3i Atlas. That's not something that you can actually really detect very well. I'll tell you this, I don't expect a single thing to happen when Atlas comes through. It's nowhere near as interesting as Siding Spring or Comet Ison or Lovejoy or Elenin from 2011. Those were scary moments. This one's coming kind of close to Mars, but Siding Spring, I think, came closer to Mars, and it barely did anything, if at all. So it's exciting, and I'm glad people are interested in this stuff in general, but I hate to be the party pooper. I don't think Atlas is going to do a damn thing but swing right through and head off into space.
Now, did CME hit it? Is that, I heard that as well?
I don't know if a CME hit it or not. That'd be cool if it did. With where it is now, an average CME would probably be covering 20 to 25% of the solar system. And so the chances are it's going to get, I mean, once you get out past Mars to like Jupiter's orbit, the magnetic cloud of the CME has expanded so much, it's covering like this much of the sky, you know? So most comets do take a CME impact. It's somewhere between Pluto and close approach to the sun. We saw Elenin get hit by a CME and it blew it apart. Like the sun literally blew the comet into pieces. That's the only time I've ever seen that happen. Comet Neat, I think 2003? Comet Neat was amazing. You should look up some videos of Comet Neat in 2003 if you could. It got so close to the sun, you could see it on SOHO coronagraphs, and the sun hit it with a titanic CME, and the thing just kept right on smiling. It didn't stop, it didn't slow down, it didn't fracture. It just kept right on going, like, is that the best you can do? Kind of thing. But so, yeah, I mean, it's not like I'm gonna be doing this when Atlas comes by, you know, la 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 la, but I really don't expect much, because I've been bitten by that before, by expecting too much from these comets.
I got a question.
Okay. So the question was, she's heard that it's going to be biblical, that it will be darkness, day and night. Absolutely, when the magnetic null point of the current sheet hits the sun, it's going to short circuit the luminosity, it's going to short circuit the solar wind. So as the luminosity is dropping, dust is going to be accumulating, so it's sort of like a double darkening factor. Not only is its own light on the decline, but dust is able to accumulate because the solar wind can't push it away. So you've two different things darkening the sun. That is absolutely biblical. When the galactic electric environment reignites the sun and it blasts that shell off in the micronova 3 or 4 days later, that's Revelation 16:8, and the fourth angel poured out his vial upon the sun, and the power was given unto him to scorch men with fire. Now, I don't think a little winged creature's going up and pouring anything on the sun, but it will be able to scorch men with fire, that's for sure. In terms of the earth swaying to and fro like a drunkard, that is the crustal shift. A third of the stars being thrown from the sky. Trust me, back then, all these people had to do at night was look up. They're not going to mistake a fixed star for a shooting star. And so most scholars like to think of that line in the Bible about a third of the stars as like, oh, it was some kind of a great meteor shower. No, these people knew the sky. If you tilt the world like this, part of the sky you could see at night is no longer visible. That is a third of the stars being thrown from the sky. Half of Isaiah is about this event as well. This is all over, not only the Bible, but the Bhagavad Gita. This is what it talks about, and this is what's happening. Yes.
You know, it's what I thought about this quite a bit, especially with black holes.
Okay.
Magnetic field, and maybe that's where the dark sun thing is.
It-
Magnetic issue with pulling light.
It's possible. What August was talking about there was how sort of the electrodynamics of the galactic current sheet, in theory, could quench the luminosity of the sun magnetically. I have read enough to know that that's not outside of the realm of possibility. Off the top of my head, putting me on the spot, I probably like my original explanation, but it's, you know, there's multiple ways to skin this cat. As, you know, ethical skeptic in his EDCO theory talks about the Earth tilting over via the Jennebekov effect.
You know what, we're gonna know for sure in like 2040.
Yeah, we're gonna find out, that's for sure. We're gonna find out. So the question was, as this event keeps going, what are the spiritual expectations? I expect the things that we've been seeing the last several years to get much, much worse. What does the Bible say happens at this time? People turn away from God. They embrace sin. They become greedy. I think that we are going to be seeing, and unfortunately, those people who I was mentioning who are in charge of this planet, they are tearing down God every chance they get. They are promoting, if not outright Satanism, they're promoting degeneracy and sin every chance they get. I think that some kind of a beautiful revival is not on deck, but a hold your ground as everything else falls apart around you kind of a thing. When your friends, your family start showing the demons, don't let them come out in you kind of thing.
And doesn't come back on.
The question was what happens or if it's possible for the sun to go dark and then not come back. You know, I don't have a crystal ball. It would be shocking to imagine how that could happen, unless literally somebody breaks the simulation that we're in and the galactic current sheet stops moving. You know, from a physics and math perspective, that one's challenging to see.
Well, we have recurrent novas all over the place, and they always come back.
Yeah, they always come back. So.
Yeah, but if the sun doesn't come back, you have like a week, right? Otherwise, everyone's
I know it happens.
So Tone just brought up an interesting question. If the sun doesn't come back, we have like a week, right? Maybe. Who knows how much ultraviolet light will be coming off of it? Who knows how much infrared light will be coming off of it? And given that energetic change, what about the heat from inside the Earth escaping? You know, I brought this up before when somebody was asking about what happens if the micronova blows off a huge portion of our atmosphere. And, you know, my thing was, well, that hasn't happened before to the point where it killed the whole planet. But if you were to suddenly depressurize Earth's atmosphere, the first thing that's going to affect is underground and under the ocean, and air is going to start rushing out. I wonder if a similar thing might happen to, you know, lava or geothermal. And so, in general, yes, if the sun turned off, we would just have a couple of days before we all froze to death. Absolutely. I don't know. Maybe I'm a little white-pilled on that subject. That's possible. All right, let's do one more question. Over there. Waiting for Tone. You'd have to go back more than 70,000 years. So the question was, has the micronova ever not happened on one of these cycles? And, you know, that's tough to know. The papers that Doug Vogt found with the short-lived nova-level isotopes, those go back the last 3 or 4. You start going back more than that, a lot of their half-life has expired. A lot of them have, you know, decayed, and it's just much harder to spot.
So we really can't tell for sure.
In theory, no, we can't tell. I can tell you at least the last 4, and probably at least since Toba. You know, I leave open a window that something changed right before the Toba event 70,000 years ago. This is actually a good one to close on. So all of the stories of Planet X, Nibiru, they come from Shoal's star red binary. A binary red star system came literally screaming right through our solar system 72,000 years ago. Based on how they're seen orbiting each other, they know that there have to be planets around them, maybe 7. It's very possible that the solar system looked very differently back then. Earth may not have been where it is now. It may have been a moon of Saturn, like the thunderbolts suggest, although they suggest that this all happened just a couple thousand years ago. I'm saying 72,000 years ago. It's possible that Jupiter was actually part of that system, and we captured Jupiter. It's possible that the stories of Mars and Venus doing battle in the sky were cause of the disruption of another solar system, basically sleeving through ours. I would say that what is about to happen is almost certainly going to be what has been happening every cycle since, at the very minimum, 72,000 years ago. Of course, it could be much longer than that, but I would say that in terms of where I'm going to draw a line, at least back to 72,000 years ago, we've had the micronova on every 12,000 year cycle mark. But anyway, so I guess this was state of the sun plus more, right? All right, well, for those of you watching online, I'll see you in the morning for the Daily Show.